Welcome to Advanced Java Programming at Portland State University. In this screencast, we'll learn about some of the new language features and APIs in Java 8 that enable functional programming. So Java 8 adds several new language features that allow you to program in a functional style in the Java programming language. It also adds some new APIs that take advantage of this new functional style of programming. Lambda expressions provide a nice, concise syntax for expressing functionality and enable what are called stream APIs that let you do operations on collections of data that may be distributed among multiple threads of execution, so you can take advantage of all the CPU that's available to you. We'll be talking about a couple of things related to functional programming in Java. First, we'll look at some of the new language features that enable functional programming. We'll dig into some of the details about collections and how they've been enhanced to use some of these new language syntaxes. And finally, we'll look at some of the I/O APIs that have been added that really leverage functional programming. So, what is functional programming exactly? Well, it's a programming paradigm like object-oriented programming paradigm. But in functional programming, computation is expressed in terms of a mathematical function. These functions avoid mutable state and side effects. So basically, the output of the function is dependent only on the inputs of the function and no intermediate state. As a result, you can invoke a function multiple times with the same inputs and always return the same result. Functional programming languages make function a first-class concept in the language, just like objects are in object-oriented programming languages. You can have variables that refer to functions. Functions can be passed as argument parameters, returned from other functions, etc., etc. A function that takes another function as input is called a higher order function. And because functions are stateless, it's possible to distribute their computation over multiple threads to improve performance without memory contention. In some respects, you've always been able to do functional programming in Java. A lot of the uses of inner classes can be considered functional programming. So as you may recall, there are two interfaces in the Java I/O package called file name filter and file filter. And these are used to implement an algorithm that determines whether or not a file is of interest in a certain situation. So file filter has a method called accept that returns a boolean that determines whether or not a given file is acceptable. Similarly, there's a file name filter that takes a directory in which a file resides and the name of the file and returns whether or not it's acceptable, it's interesting. Implementation of these interfaces essentially provide a function that determines whether or not a file is acceptable. Most of these implementations will not have fields associated with them. It'll just be a little algorithm implemented in the body of the accept method. Now, you can do functional programming with anonymous inner classes, but it ends up getting really awkward. So here's an example of a class that has a method called findFiles, which will find all of the files that end with .class. And it's implemented using inner classes. So, first we call the listFiles method on the directory in which we're searching for class files. And we want to have a name filter that basically returns all of the files in that directory whose name ends with the suffix that we care about and is .class. And here it's in a final field because anonymous inner classes can only refer to final variables. So you've got 1, 2, 3, 4, 5 lines of syntax just to say, hey, is the file that I'm evaluating, does it end with the suffix that I care about? Similarly, when you want a recursion to subdirectories, in order to find those subdirectories, you use listFiles and give it a file filter, and it returns the files within that directory that are directories themselves. And here I had to abbreviate the syntax in order to make it fit on the slide. And then you iterate over all of those. So with using anonymous inner classes, there's just a lot of boilerplate, a lot of language that sort of gets in your way. Java 8 introduces a new language syntax called Lambda expressions. And what they do is they provide a compact syntax for expressing functions. Lambda expressions use a new keyword, the arrow keyword, which is a dash followed by a greater than sign, that separates the function's parameters from its body. Right? A function takes some input and then it returns some value as determined by the body of the function. Parameter types are optional, and the return type of the function is inferred. So one of the nice things about the syntax is that you don't have to specify the type of the parameter. To the left of the arrow are the parameters, and if there are multiple parameters, then you need to surround those in parentheses. But if you only have one parameter, you don't need those parentheses at all. To the right of the arrow is the body of the function, and if it's multiple lines, those lines should be surrounded by braces. But again, if you've only got a single statement in your function, then those braces can be omitted. Also, if the body is an expression, something that returns a value, you don't need to use the return keyword. It's optional. As I've described, the syntax for Lambda expressions is much more compact than anonymous inner classes, where you actually have to implement an entire method. Also, unlike inner classes, variables referred to from the outer scope are not required to be marked as final, so you don't need to put the final keyword on variable declarations. However, the compiler still requires that variables accessed by the language expression, the Lambda expression, are effectively final, meaning that if you have a variable that's used inside a language expression, you can't go assigning a new value to it after the Lambda expression has been evaluated. Essentially, underneath the covers, Lambda expressions and anonymous inner classes are implemented very, very similarly, but the language syntax for Lambda expressions is much lighter weight than anonymous inner classes. So here's an example of using Lambda expressions to provide the implementation of the file name filter and the file filter. So instead of having to have a new file name filter anonymous inner class implementation, you can just say, okay, I'm going to have it'll infer the fact there's a file name filter, and the compiler is smart enough to say that, okay, file name filter has one method called accept, and here's going to be the implementation of that accept method. It's going to take a file dir parameter and a string name parameter, and the implementation of that accept method is going to simply be return name, that's that parameter here, dot ends with class. You can go even more compact with the implementation of file filter, because you don't need to have the type of the parameters declared, so you can just have file, and the compiler will infer that the one parameter is called file, and because there's only one, you don't need the parentheses around it. They have the arrow, and then the body of the function is simply file.isDirectory. You don't need a return. So this is so we've gone from like 5 lines and probably close to 50 characters down to one simple line. There's a couple other things to note when using Lambda expressions. So if you look down here, the suffix variable no longer has to be final. The compiler will infer that. And note also, this is something that tripped me up a little bit, that even though file.isDirectory is a statement, it shouldn't end with a semicolon, because that tells something different. So basically what this Lambda is it's an expression. So it's not a statement, it doesn't end with a semicolon, it's just an expression, like an arithmetic expression. So if you were to pass the arithmetic expression 3 plus 4 to a function, you wouldn't put a semicolon after it. Same thing with this Lambda expression. So anyway, here is a new implementation of that find files method. It does exactly the same thing, but the syntax is much more compact. So now I don't need to worry about fitting it on the slide. It fits on the slide with plenty of room. So where can you use Lambda expressions in your code? The compiler is smart enough to know that whenever you have a type that has a single abstract method, so whether this is an interface or even a class that has a single abstract method, you can use a Lambda expression there. And we've seen these kinds of types that have a single abstract expression all over the Java APIs. So for instance, the collection APIs have things like file name filter that we just saw. It also has comparator that compares two objects to determine which one goes before the other. You've got interfaces like runnable that has a single run method, and also callable, which does something very similar. And then if you look at the swing or the AWT APIs, they have event handlers like action listener, which has one method that's invoked when some action is performed. The Java language now defines something called a functional interface, which is an interface that defines a single abstract method. It's called a functional method. So now these things have real names. There's also an annotation type that you can put on functional interfaces that really express the design intent. So you're creating an API, and you've got an interface. It has one method. You could call that a functional interface. Now, functional interface, that annotation isn't something that is enforced by the compiler or is checked at runtime. It's really about expressing intent, saying that yes, this interface is meant to be used with Lambda expressions in functional programming. Now, Java 8 also introduced a new syntax to refer to a method to be invoked. In functional programming, one of the things that you sort of do in your programs is you pass around methods to be invoked. We saw the Lambda expression, which is kind of like a method to be invoked. And this is sort of when you have like an anonymous method. If you have a method that has a name that you want to refer to, you can use this new syntax as follows. Here, we've got a call to directory.listFiles that takes a Lambda expression. And what that Lambda expression does is it invokes the isDirectory method on the file that is provided to that Lambda expression. With a method reference, you can use this syntax instead. You can say, you can send list files, well, a reference to the isDirectory method directly. So that's what we're doing here, right? We're just invoking isDirectory on what's ever given to this, let's see, here's a file filter. Here we're doing the same thing. So the syntax can get even more compact. And this is nice because it expresses the intent very succinctly. And again, they've made the compiler a lot smarter. And so when the compiler is parsing your program, it will say, okay, well, list files expects a file filter, and the user is telling me that it wants to invoke the isDirectory method from file. And so it'll go and do all the analysis to determine that, yes, indeed, the accept method that's there on file filter can be implemented to call the isDirectory method from file. There are four ways to reference methods when you're when using that syntax. If you want to reference a static method, you can say class name : the name of the static method. You can also reference a method on a particular object, and then you have a reference to that object. So it's in a local variable, or maybe it's in a field or something. And so you say the name of that local variable : method name. You can also use this syntax, as we just saw, to refer to an instance method on some object. Like we just said, directory.listFiles, file : isDirectory. And you can also reference a class's constructor using the name of the class : new. And this is kind of neat. And so this will you can use this syntax to define a functional interface where you've got a method on that functional interface, functional method, that returns some object. So for instance, if you wanted to have let's say you've got an API that takes a runnable, which is just do some piece of work. Well, if you want that piece of work to be system.out.println, you can have that syntax be system.out, and that refers to a print stream that's stored in the out field, the static field of the system class, and then you can refer to its println method saying : println. So this doesn't invoke the println method directly. Instead, what it does is it creates an instance of runnable whose run method will invoke system.out.println. Similarly, callable is an interface that will create an object or get an object. I believe it's got a method called get. It's parameterized, so you can have a callable of a list. And so this is a callable that you can assign a reference to the zero argument constructor for array list. So what this does is it provides an implementation of callable whose get method will create a new instance of array list. Again, a really nice compact language syntax. Now, one of the things that we all learn about in Java is iterating over collections. And prior to Java 8, all iteration was done using external iterators, meaning that it was the calling code that's responsible for iterating over the contents of a collection. So here we have a first example of using a good old-fashioned for loop for iterating over an array of strings and printing each one out. You can also use an iterator. You can get an iterator object over a list of strings. That'll be an iterator of strings. You can loop over each one of those, saying, hey, while you still have more elements in the iterator, give me it and print it out. And then we've also seen the for each syntax, which is a nice compact representation of this external iteration, saying, well, for each string in a list of strings, print it out. And what external iterators do is they give the caller all of the control and all of the responsibility for iterating. Java 8 has the ability for collections to have what are called internal iterators. In internal iteration, the collection itself is responsible for delivering each element of that collection to a function that handles it. So instead of the logic for handling each element being expressed in the caller, it's instead expressed in a function that is passed in and ultimately invoked by the collection itself. This is implemented by a for each method that's been added to all the collections that takes an instance of an interface in the Java util function package called consumer of t. It basically has one method called accept, and so that takes some object and does something with it. And the for each method, what it does is it delivers each element of the collection to that consumer object. So here's an implementation of that using an anonymous inner class. So for each element in my list of strings, I'm going to create a new consumer that consumes strings, implement its accept method to do system.out.println. Or through the magic of Java 8 language syntax, you can just say list of strings for each system.out : println. So here again, the for each will go and iterate over all of the elements in the list of strings and deliver each one of those to the println method. So like I said, for each was implemented on every collection, and it would be really great to be able to add this new method to every type which is iterable. So iterable is an interface that basically says, hey, I can give you an iterator over myself. I can be iterated over. Now, if we were just to add a new for each method on the iterable interface, this would break every implementation of iterable that's out there, because you'd have to go then, every time you have a class that ultimately, a non-abstract class that implements the iterable interface, it would have to implement the for each method also, and that'd be a lot of code to change. And certainly anybody outside of the JDK code or outside of the code that's controlled by the Java language people, it would have to change also. In order to get around this, a new language syntax called default methods what was added. And what default methods do is they provide an implementation of a method on an interface. So every class that implements that interface, they will get this default implementation for the method. What this looks like syntactically is that in your interface declaration, in addition to the interface methods that we're used to that just have a return type and a name but no body, you can also now have methods that are fully implemented. So here is a for each method that is been added to iterable. It takes an action, and what does it do? Well, it makes sure, first of all, that that action is not null by calling objects.require non-null, and then iterates over every element in this iterable and invokes the accept method from that action on it. Note that default methods and interfaces are prefixed by the default keyword, and that a class that implements this interface can override the default method to do something else. So this is really nice. This allows a for each method to be added to every iterable out there, and so this is all the collection APIs and a bunch of other APIs. They can do that and only have to change one piece of code, and that's the code in iterable. And now this for each method will be inherited by all those subclasses. So we've seen the consumer class, but let's look at some of the other interfaces that are in the Java util function package. There's an interface called supplier, which takes a type t, which has a get method that returns an object of type t. And so there are suppliers for all the primitive types. So you have a Boolean supplier, double supplier, etc., etc. And so this is used in the case where you create some object. Kind of like in that callable a couple slides ago where we created a new array list. You also have a supplier that is array list : new. Predicate takes a type t, and this is an interface that provides one method, test, that determines whether or not an object matches some criteria. It's a lot like those file name filter and file filter. So it's got one method that says, hey, is this object something that I care about? And again, there are implementations of predicate for each of the primitive types. Function takes two type parameters. T, the type that it works on, and then R, which is the result type. And a function transforms one object into another object. Now, sometimes the types of the objects are the same, and that's where you get implementations like double function. So that would be a function that takes one double and returns another double. Maybe you have a function that, I don't know, doubles a double, or sorry, multiplies it by itself, something like that. But then you also have implementations of function that are like double too long, which will take a capital D double, some number, and convert it to a long.